Given the accelerated growth in demand for certain products, more and more companies are also seeking to have their production lines as automated as possible in order to increase the quantities and production times, as well as reduce the number of defective products generated. The specific problem lies in a technical batteries assembly line for cars, where after a battery is assembled, an operator must manually place these batteries on pallets to be transported to the charging station. The main problem is that depends on the operator's working hours to be able to carry out these tasks, happening the ordinary assembly line that already has an already automated process. The beneficiary is Tecnova, the only Ecuadorian company that is authorized by Bosch to manufacture its batteries, which has 85% automated battery assembly lines, and which also prioritizes the automation of its automated process.
Explanation of the design. For the robotic arm space, the material chosen is cast iron, a highly common material that has low price. Regarding the material of the links, we define aluminum due to its lightness and resistance. For the design, inventory is used. There are three fundamental parts in the electronic design of the robotic arm: actuators, sensors, and controllers. Electrical types of actuators have an advantage over pneumatic or hydraulic actuators for its ease of control. Stepper motors are one of the most used in robotic arms due to its precision and non-necessary feedback, which reduces cost. In this project, a JBL brand stepper motor MST513 model is selected, with 100 newton-meters torque for holding and running operations that withstand axial force conditions that the structure is subjected to. As a controller, taking in account the model previously mentioned, the SMC85 controller was selected to set speed and position of the arm in the program designed for the controller. When it comes to the sensors, using a displacement sensor to measure range between the place where the object is found and a reference position, for this project we use an absolute encoder to its precision and efficiency to determine position. A capacitive proximity sensor was also added since this device can detect any type of material, even through certain non-metallic objects to detect any objects near the arm. Finally, a PLC receives the information from the input devices, processes the data, and activates the outputs, the steppers, according to its programming. Based on the multiple inputs and outputs, the PLC is selected to speed up and optimize the sensing and control process of the arm actuators to obtain fast and precise movements essential for this application. A software designed to control the robotic arm in a simulation, MATLAB will be used along with an application developed for MATLAB and tools such as Simscape and Simulink. MATLAB has an user-friendly interface for controlling the robot's movements using direct kinematics previously developed in this project. The control used for this application is a position control. Sliders are used to indicate how many degrees of inclination each joint should move. The final position of the robot is indicated in px, py, and pz, coordinates of the arm. To obtain the physical model of a robotic arm, the XML format is exported from the inventor design. Together with the tools in MATLAB previously mentioned, we obtain the following design in Simulink. With the app and graphical representation of a robotic arm, its position can be controlled as long as the simulation is running.
So now we're gonna explain the simulation for the robotic arm. As you can see, we have used the Simulink and the SimScape software in order to simulate this robotic arm in the MATLAB environment. Also, we use the app designer for MATLAB in order to make an application that is capable of controlling the movements of the robotic arm joints. So here we can see that we have joint 1, joint 2 and joint 3. These sliders can control the angle of the 3 joints of the robotic arm. Also we can see that the angles that are introduced in these sliders are reflected here in these boxes. When I hit the button, the movement applies to this simulation in Simscape. So before we do that, I'm gonna explain the code. So the most important part for the code are the callbacks. This function is for the join one slider. So here we can see that the most important part is this are these matrix. So when we made this matrix, we had to use direct cinematics in order to obtain the information, and when we finish doing this matrix, we have to multiply each one of them in order to get the final rotation matrix. This helps us to obtain the position of the robotic arm. As you can see, here are the coordinates for the X, Y, and Z positions. So here they are reflected when I move the three sliders. See how they change? So now I'm gonna simulate this position by hitting the button. So when I hit the button, you can see that the Simulink is compiling, and now we can see that the robotic arm has changed its position. We can try again. So I'm gonna apply a new angle in each joint. So now I hit the button again, and as we can see, the three joints 1, 2, and 3 for the hand of the robotic arm have changed. So this is a control of direction, so we can control the position of the robotic arm at any time just by selecting which angle we want for any of the three joints. So thank you, and this was part of the simulation for the project.
So in the conclusions, we have that it was possible to develop a mathematical model of the robotic arm, considering the specific parameters defined to fulfill the task required by Technova, and knowing the equations that govern it. Based on the also based on the mathematical model, a second order controller was designed taking as main parameters the characteristics of the motor used, and also knowing the natural frequency of the system and the damping coefficient. Uh, and the last one, the findings of this study can be result in the development on simulation of a robotic arm that fulfill the task of organizing pallets with batteries for the company Technova, and with a high percentage of reliability in his operations in his operation in case of being implemented by this industry. And in recommendations, we have that as this project is supposed to be for an industry, it is recommended that it is always used industrial level equipment. In this specific case, uh, using a programmable logic controller, PLC, and not using just microcontrollers because it won't fulfill the task as it is supposed to, and doesn't have the reliability that a PLC has. It is also recommended to make a designs always looking forward to have like reliability factors or safety factors greater than one. It This means that it is always recommended to do a bit oversized in terms of requirements uh, in order to avoid possible failures.